With the rapid development of Internet of Things technology, LoRa has been widely used as a long-distance and low-power wireless communication technology. LM100 and LC144 utilize the latest LoRa technology to build remote, wide coverage, and low-power wireless Modbus IoT applications. LM100 and LC144 adopt a one-to-many networking architecture. One LM100 master node can connect to multiple LC144 LoRa end nodes for two-way communication and upload data to PC, PLC, or Modbus gateway to upload data to the cloud. Depending on the environment, the LoRa wireless communication distance can reach 2 to 5 kilometers. LC144 has a RS485 port for connecting one or more Modbus RTU or sensors, as well as multiple analog inputs and outputs, such as voltage input and output, current input and output, and PWM output. One LM100 master node can connect up to 249 LC144 LoRa end nodes for two-way communication. One-to-many unlimited long-distance transmission can effectively reduce the cost of old wiring. The lightweight industrial design of LM100 and LC144 can provide IP40 environmental protection and a wide operating temperature range of -40 degrees to 70 degrees. The 6 dBm LoRa antenna provides long-distance transmission, terminal input for power from 10 volts to 30 volts, and ground. LM100 has an RS485 interface to connect to the host computer. LC144 also provides multiple analog inputs and outputs. Both LM100 and LC144 can be connected to a computer via a micro USB cable for setup. First, download the LoRaWAC software, install and open the software, connect LM or LC. Select the COM port to connect to, and you can log in. Click red to read the current configuration. Click right to write new configurations. LM100 needs to configure the parameters of the host computer and the ID of LM100-1250 in the serial menu. Here we set it to 1. LC144 needs to configure the connected serial devices such as RTU or sensors in the serial menu. We can set it to 2250. It should be noted that each LC144 ID cannot be repeated. GroupNet needs to configure the agreement between LM and LC, such as whether to encrypt and the key. If encryption is set, both LM and LC144 need to have the same encryption configuration. The group owner ID requires entering the ID of the LM100 on the LC144, but does not need to be entered on the LM100. LM100 checks all the IDs of LC144 and the IDs of connected devices on the destination ID. LC144 only needs to check the connected RTU and sensor ID. LM100 and LC144 need to have the same LoRa configuration to communicate in both directions. Select a legal frequency in your area and select a large bandwidth for the bandwidth to increase the transmission speed, but may reduce the sensitivity. Spreading factor settings range from 5 to 12, configured according to the transmission distance. Generally, the farther the distance, the larger the SF required, and the transmission rate will increase. Code rate is the fault-tolerant redundancy. The first number is the actual data, and the second number is the added redundant code. The more redundant codes there are, the slower the data transmission. The greater the TX power, it helps to increase the transmission distance. Click on Right to save the new configuration. This covers the basic setup of LM100 and LC144.